Good morning. My name is Andrew Nelson. I'm the Randall C. Pepe Chair in Entrepreneurship at the University of Oregon's Lundquist College of Business, and I also serve as UO's Associate Vice President for Entrepreneurship and Innovation. So on behalf of the Phil and Penny Knight campus for Accelerating Scientific Impact, it's my incredible and deep pleasure to welcome you to our first Entrepreneurship Speaker Series event of this new academic year. I think most of you are familiar with the Knight campus, but our mission fundamentally is to shorten the timeline between discovery and societal impact through world-class research, training, and entrepreneurship. And the point of our speaker series is to highlight individuals who've taken similar efforts in their own careers. So today it's my pleasure to welcome Michele Marcolongo from Villanova University. And frankly, it's hard to think of someone who better embodies the intertwining of these goals that I just outlined. Now, before I say a bit more about Dr. Marcolongo, let me address just a few logistics for today's seminar. After Dr. Marcolongo's presentation, we're going to open the floor to questions. Here's how it will work. If you have a question, please use the chat function in Zoom, and I will then serve as the moderator to call on specific individuals. When I call on you, then please unmute yourself and ask your question, and then perhaps remute yourself so that we can hear the response. I should also note that we'll be recording this morning's session for the sake of those who were unable to join us. So on to the main attraction here. Michele Marcolongo, I was just joking before the session opened up that I could spend the entirety of our hour just recounting her accomplishments because she is such an incredible academic, an incredible entrepreneur, and an incredible person. But I'm going to keep this relatively short by introducing her as the Drosdick Endowed Dean of the College of Engineering at Villanova University. Her engineering career spans more than 3 decades and encompasses roles as an academic, a researcher, an administrator, an inventor, and an entrepreneur. She was a faculty member at Drexel University's College of Engineering for more than 20 years, and she began her career at General Electric Aerospace, also serving as a biomedical engineer at DuPage Point Orthopedics. So lots of incredible experience there. She received her Bachelor of Science in Mechanical Engineering from University of Delaware, a Master of Science in Mechanical Engineering from Drexel, and a Master of Science and PhD in Bioengineering from the University of Pennsylvania. Her extensive research focuses on biomaterials and engineered biomedical solutions to treat disease. Widely recognized for her expertise in innovative work, she was named a Fellow of the National Academy of Inventors and the American Institute for Medical and Biological Engineering. In addition, I promise I'm almost done, but I warned you, there was a lot here. Dr. Marcolongo is a successful entrepreneur. She's co-founded 3 biotechnology startups. She also holds 15 patents and patent applications, and she authored a book. Apparently in your spare time, Michele, I'm dying for the secrets of how you accomplish this. Her book is titled Academic Entrepreneurship: How to Bring Your Scientific Product to Commercial Discovery. And it serves as a how-to guide on translating research from the lab to commercialization. And that will be the subject of today's talk. So without further ado, it's my warm and tremendous pleasure to welcome Dr. Michele Marcolongo as today's entrepreneurship speaker.
Thank you so much. I appreciate that very kind welcome, and kind of appreciate that, the whole setup. It's so great to be here with you virtually. I would look forward to a visit to your campus and to this beautiful building. At some point, I'll take a rain check on that. That would be a delight because it's so exciting what you're putting together there and setting up the university for amazing impact on the world. So I congratulate this major effort, and I can appreciate some of the work that's gone into just making this kind of a community. So thank you for letting me be part of it for the day. I am very excited to be here. And I just want to see if those slides look okay to you. Can you guys see that okay? Okay, great. And just get started here. So yeah, today we're going to talk about sort of a startup campus, this idea of what you're doing, taking a research discovery into a commercialized product. And I want to start by a story that encompasses one of your esteemed faculty members, Dr. Andy Carduna, who was my colleague at Drexel for a period of time, and also my colleague at Penn when we were graduate students together. And so we know Andy from a long time. And And I want to talk about one day in the lab with Andy. Most days in the lab are utterly forgettable. One day streams into the next. You know, you progress and get work done, but you just can't remember the many hours that you spend at a bench and doing your work. But one particular day really stands out in my mind, and it's very crisp. I have like a snapshot image of it in my head, and it was with Andy and our student Abhijit, our colleague Tony, and I were working on seeing if a medical device that we were working on, a new hydrogel, could restore the mechanics of the intervertebral disc. This was a goal that we had, and this day was the day that we were actually doing the mechanical test to see if indeed this was going to happen. And I can remember the day so sharply that I remember where everybody was sort of standing or sitting at the time. I remember the hum of the mechanical test machine down in Andy's lab. And I remember just anticipating the results. We were so excited to see if this was going to work or not. And in the end, the results went well. We were able to actually restore those mechanics with this device. It was sort of a big celebration. I myself was thrilled because we thought then that if that held true, that we would be able to develop a treatment for lower back pain. And so that was more or less the start of a journey into entrepreneurship. Started right there in Andy's lab that day at Drexel. So I wanted to start by talking a little bit about the approach to research and the approach to research in education and in higher ed. So we, sorry, there we go. So, you know, higher ed is really intended for education in the classroom. This is usually tuition supported. And the whole goal is to really educate and elevate our society. While research, the focus is usually in the laboratory or whatever kind of research you may be doing, social science research, usually supported by federal, state, industry, or foundations. And the result is really scholarly work and education of our graduate students, the contribution of knowledge to the world. And so, so we have the way that research is funded. Basically, we all, as taxpayers, pay into research because we pay our taxes to the federal government, who then decides to allocate some money for us to do our research. In the university, we may make discoveries from that work, and then we will do our thing. We'll write scholarly papers, we'll disseminate the findings at conferences, we'll educate graduate students to continue that process. But unless we really continue this circle and provide back a commercial product or service to society that generates value and treatment for society, then we can't really continue, you know, we don't really continue the circle if we don't do this component that has high impact. So so that's sort of the way I look at our opportunity, and almost the way I look at it is sort of an obligation, that if we have a great discovery and it does have commercial viability, that we should be able to help make an impact on the world through that scientific discovery. And so if you look back historically, before World War II, research was really highly theoretical in the US. Mostly the federal government was uninterested in supporting it. And a lot of research was done as internal research in companies. Versus today, which really has a lot more experimental, discovery-based research. The federal government is highly interested in supporting it, really as a result of post-World War II, and when Vannevar Bush and Roosevelt started the National Science Foundation to help us prepare better for areas of defense, but also expanding to science more broadly. And internal research at corporations now still goes on, of course, but has dropped dramatically. More open innovation concepts are accepted, where there's a collaboration between companies and academics and others. So this is reflected in the federal spending on university research, which over the years has gone up, thank goodness. And then the amount of research internal R&D in companies has gone down dramatically. And so has the amount of publishing from companies. So you see this sort of shift from working mostly on internal R&D and the great labs, from Bell Labs to DuPont Labs and IBM, all these great labs that used to exist, now to the focus on university research more dramatically. And the real kicker was the Bayh-Dole Act of 1980. So Bayh and Dole senators got together and took a look at the policy that we had about federal funding for universities, which said if there's federally funded grants, that there's a non-exclusive license to the companies associated with that. And non-exclusive license means nobody gets full ownership of the intellectual property, but that it would be shared among anybody who was interested in it. And while that seemed like a fair way to go about it, the fact was that only 5% of those patents from universities were licensed at all. That because it was open to everybody, nobody wanted it, essentially. And so there was a stagnation in innovation coming out of the universities that was translatable to commercialization. There was a sense that the research dollars were not getting back to taxpayers in innovations and high impact work. And they also had a worry at that time that the US would not be internationally competitive. So they switched the law and gave universities ownership of the intellectual property and allowed us to exclusively license to either a startup or an existing company, and try to move more of that innovation from the shelf out into the world. So here's just a little bit of data from 2012, which could certainly be updated now, but you can look at the numbers of US patents filed and issued, at the number of licenses executed. The total license income from universities at that time was $2.6 billion, not insignificant. There are 705 startups formed at that time, with 4,000 startups also operating currently in those years, employing about 15,000 people. The thing to remember is that 80%, and this number is held fairly steady, 80% of licenses went to existing companies, not startup companies, but licensed directly to existing companies. And this is biomechanics for Andy. This is a yes, put some spring in your steps there. Okay, so now, having that background, we can consider ourselves as academics, we're really in the area of doing research, advancing knowledge. But if we want to have that impact on the world, and if we don't have a direct licensing opportunity, then what we may want to do is start a company around that technology and try to advance it ourselves, either to the point where a large company will buy it, or to the point that it's viable independently. And so as scientists, we have to think of the definition of an entrepreneur. And what is this going to mean? We already had to spend all this time training to be a scientist or engineer or whatever you may be researching. And now, so the entrepreneur is the person who organizes and operates a business, taking on greater than normal financial risks in order to do so. So sometimes as scientists, we're happy to take on risks, but sometimes we're a little more conservative. So it's not for everyone, but these are the traits of an entrepreneur. The ability to take risks, but not excessive risks. Someone who's innovative, who has knowledge of how the markets function, manufacturing know-how, marketing skills, business management skills, the ability to cooperate a good idea about business, how to correct errors effectively, and grasp profitable opportunities. So these are the general traits of entrepreneurs. Most technological entrepreneurs, I'll show a woman here, but I had to search pretty hard on Google to find a Google image of a female entrepreneur. Only 1 in 10 entrepreneurs are women in the tech space, but there's one. She looks good. So there was a survey done of 1,700 or so academics to look at traits of those who are likely to become entrepreneurs. And the academics who tend to become entrepreneurs have common backgrounds in that they're either trained in institutions that have culturally accepted tech transfer. That's one ability. So their graduate training involved IP and seeing kind of startups and translation of technology around them. Most of the faculty members were closer to their graduate training. Those further away from their actual training time, more senior faculty had less participation. If their department head or chair was active in technology transfer, that was another indicator that they were more likely to participate themselves. Or if respected members of their academic community were participating in tech transfer, they were also then more likely to see themselves doing that, having that kind of role model within an accepted role model within their academic discipline. And that they call the Porsche effect. And well, the Porsche effect, as quoted by the New York Times, said, if somebody in academics, sold a company and drove to work in a Porsche, then the next guy down the hall is more likely to say, if that person can do it, I'm sure I can do it. And this sort of helped propel things, and that's what they call it. I didn't coin that, so I don't take any blame for that, but that's what it's about. And then there are contraindications for academic entrepreneurship. What would discourage a faculty member from participating? And that's more if a department or academic community is not supporting tech transfer, even if the faculty member is trained in tech transfer and this whole process, they'll conform to their local norms. So if the community is not supportive, they're less inclined to do that, especially if entrepreneurship is not valued for tenure or promotion among faculty members or included in promotion metrics, then academics are less likely to participate. And this is a national challenge. I've talked to many of my colleagues across the country who say that entrepreneurship is not included in their tenure and promotion criteria, or even sometimes viewed as a negative, and that is a deterrent, especially earlier in your career, from participating in that. So I'm not sure if you can see this where all of your faces are, but I'm gonna move my faces out so I can see this whole thing. As academics, so we're trained in research, grant writing, publication. Often missing is the mentoring and training in the translation. And so I started thinking about this in terms of steps. Just sort of, entrepreneurship is non-linear, but I drew it as a linear path here. So that we have discovery, patents, publications, products, market testing. You can see this whole train of events that we really need to understand or even master if we're going to be entrepreneurs in an academic setting, but we don't have that training. So I'm going to take us through a little bit of those steps and see how this process might work in the areas of entrepreneurship that are unique to academics. So for us, discovery is part of what we do, and then to have it move toward high impact, that things like you're trying to do with your institute, is to protect the intellectual property. So as you're doing your discovery, and hopefully before you write a paper or present it, somewhere around in there at least, you need to make a disclosure to the university. Usually the university will consider that disclosure and see if they want to patent it. There will be possibly a provisional patent application, and then the non-provisional or sort of full patent application after that. So it's usually the general process. And the culture of innovation is to have the graduate students and faculty members, postdocs, to kind of consider the intellectual property as they're working on discovery and dissemination of findings. So because in higher ed we develop our ideas based on discovery, or some goal of scientific merit, we usually have a discovery first, and then from that discovery we'll form it into a product, a potential product that we can then test to see if there's a market need. And this is different order a little bit from a non-academic startup, which often consider a market need first, and then we'll develop a product to meet the market need, and then go through an R&D phase to kind of prove that out. So it's a subtle difference in flipping of these two, but as it turns out, this top path ends up taking sometimes longer than going at it from this bottom path of everybody outside of the university. So that's kind of a difference in the product definition. But regardless of how you start a company, or even and look to see if this is going to be viable to license and how to position that, then there's the market search phase that Steve Blank really promoted, and that's that not all amazing scientific discoveries translate into a product that is ready to be adopted. The number one reason that startups fail is that they're chasing after a market that doesn't exist or can't be developed, at least in their time frame. And so the idea that Steve Blank puts forth is to, kind of get out of the building, go and talk to people, see what's going on. So if you want to, if you're doing a little tech and you want to, get a beach body in 10 days, then you go to the Starbucks and you say, if anybody's there now, but you say, oh, would you use this app? Would you use this app? Would you use it? And then you get some immediate, you get some feedback, and then you can see about, would anybody care about that? And they say, no, I really only would do this app if I could get a beach body in 2 days. So I'm not interested, or whatever kind of feedback they get. So for us, it's a matter of getting out of the lab and not making up a story in your head of why this will be so good, but to actually get out and talk to people who could be your end users. For me, that was usually surgeons and clinicians, but it could be whoever the user of your product would be that you imagine. And NSF really does a very nice job in conveying this and guiding you through the search phase, and so does NIH. So the primary market research is really hypothesis driven, which is good for us because we like hypotheses. And so you just develop a market hypothesis, define your key customers, shape your questions, make a little survey so you can keep track of yourself, try to be quantitative and qualitative. So in the end, you get a graph, which is nice, and you can see, for instance, 1 to 10, is this product a must-have or nice to have? And you can develop. There are lots of guides for how to develop these questions and to do your market research to see how kind of help focus how your discovery can be conceptualized into a product offering, and what the costs might be associated with that, what people would be willing to pay. Would they really be willing? They would say, if this was out, I would absolutely buy it, or if this was out, it might be nice to have, so all these questions that you can ask and you can quantify and get an idea. And from that market research, you're going to get some answers. And it might be, go, like, people love this, the price point makes sense, there's a true market need, everything's ready to go. It may be that you get a maybe, a maybe that you may need to refine this a little bit, or you might get no. You tried, it just, something changed, there's a new product developed, or the market needs changed. Of course, this is a very dynamic situation you're going into. So it may be okay. It's okay to get an answer now before you invest millions of dollars trying to develop a product that may not have a marketplace. And so this is all good information and can be fed into your next iteration of discovery. So once you feel like you have a market need, then you can go on and do a proof of concept. The early proof of concept I talked about earlier was in Andy's lab, and we saw some good mechanical results. But every technology has a key question that they're going to try to have to answer. And it's good to design an experiment that may be different from the kinds that you'd write a grant around, but is an experiment that will really help you test your product hypothesis and the efficacy of your solution. So the idea here is to push it and really try to succeed or fail fast. That's one strategy to try to really understand the limitations of your design, and try to also de-risk the technology, which means, if you're doing a material, for instance, you will have to figure out, can you scale that material strategy? You can make that material in the lab. Can you scale that up to larger quantities necessary for commercialization? Or a risk could be, it worked in cell culture, but how does it work in this, disease animal model? So these are questions that you have to answer for yourself to convince yourself, and that you'll also have to answer for investors. A lot of places have developed proof of concept centers to provide specific funds to allow academics to do this. At MIT, Deshpande endowed a center which has been extremely successful in providing these key startup funds, and ECSD, it's the Von Liebig Center, that started in the College of Engineering but is now university-wide. There could be local agencies. In Pennsylvania, we have Ben Franklin, because we're from Philadelphia. Yeah, Ben Franklin. So our local Ben Franklin in Southeast Pennsylvania has a very nice seed fund that allows us to get startup funds, and they really have a great support system, good vetting system, good support system for launching products. In particular, in the state, we had a nano and energy initiative, and we had investment from the state, and every university in the state of Pennsylvania was a member of this. And those of you in tech transfer can imagine the nightmare that was to figure out all of those tech transfer agreements among all 13 universities. But that was done, and there was some significant investment and really a tremendous amount of follow-on funding and startups that came out of that investment in proof of concept funds. So I managed that with a member from Penn and Ben Franklin for a period of time. That was really exciting. There's also in biomedical devices, the Coulter Foundation, which is a national foundation that give universities $20 million endowments. We had one of these at Drexel where I was before I came to Villanova, where the foundation invests 10 million and the university invests 10 million, and then you have this endowment to initiate startup projects and ventures, and that's been another successful way of starting. So there are a variety of ways to get this seed funding, and proof of concepts funding rather. But it's not really like a totally cohesive system. And sometimes, as you can see from this little cartoon, that this sort of is the broken bridge, or some people call it the valley of death. But when I say that to surgeons, they just say, you shouldn't call a technology a valley of death to clinicians and surgeons. So, so I try not to say it, but it is a bridge that needs to be crossed. So if you have all of this together, and you have the tech transfer office and licensing, then you need to make a decision about your IP. In that, should you just license this to an existing company, or should you form a startup? And when you ask yourself that question, there are trade-offs to each of these, but it may depend on your market sector. on the market need, competition for technology at the time, whether it's a one-off product or an improvement to an existing process, or whether it's a platform type of technology that will be a platform for a whole lot of new products that can emerge from that. So I guess not all IP is the same, and there can be different approaches for different situations. Oops, sorry. So again, as I was mentioning, 80% of university IP is direct license to a large company. And so if you're going to license to an existing corporation, which you could call an old corp or an existing company, it's the most straightforward and most common way to translate your research. The advantage of it are that it's much less commitment of your time. It still is as a faculty member, but it's less so. The university will represent you, so you have little to no conflict with the university yourself. There's a university policy generally on distribution of earnings, and you just go according to that policy. If you have multiple inventors, you divide that up when you make the disclosure so that that's all clear and clean. And then that just sort of automatically happens if there's a success and you get licensing, royalties back, or some equity or whatever it might be. And then sometimes you have to help find the candidate company to license yourself. You probably know the field better than anybody, and may be able to help direct some of those possible corporate engagements. Sometimes the existing companies offer you a consulting or research agreement to help develop the technology further. There's no assumption of personal risk. And again, with this way, there's not significant potential conflict between you and the university, which we'll talk about in a little bit, or you and your co-inventors. The other considerations, or what is the downside? There's a risk that the existing corporation will not take your discovery to full commercialization. They may license it, they may put it on a shelf, they may license it and have good intentions to commercialize it, but some other priorities come into their company, or their company gets sold or whatever. And so essentially, once you license this, you generally lose control over it. So we don't like to lose control, generally speaking, as academics, but that's what happens when you sign that agreement. So there are advantages and considerations for direct licensing to a corporation. And then there are reasons why a corporation may not want to do a direct license. This is something you sometimes see in medical devices and in drugs. And I'll tell you the story of the technology we started talking about in the beginning, this intervertebral disc replacement. When we first started getting this together, I made a few trips to some companies I thought might be interested in it, and large existing companies, and they were interested in the technology, but they all said the same thing to me. They said, we don't like negotiating directly with universities. They just find it tedious, and the pace of academics and the pace of business are not always in sync. And so sometimes they will do this, sometimes they choose not to. But I heard comments back that for that particular one we were talking about, they were not interested. And the other one is that they say the technology is too early stage. So what do they mean by that? Because we have been doing research on this thing for years before we were bringing it to the possibility of licensing. It didn't seem early stage to me. I mean, we did that big experiment. I mean, we spent a lot of time on this and all the material stuff. But what they mean is that it's early stage in that they will have to assume a lot of technical risk in developing this discovery into a product. And there are lots of steps to that that really are better done outside of university than inside. But sometimes companies will like to see that develop further before they take the risk of bringing it, because they have technical risk, there's sales, marketing risk, and companies don't want to take on a lot of risk unless there's a tremendous benefit and they're willing to make that investment. So sometimes some reasons why existing corporations may not want to license your technology is that they won't want to negotiate with the university, or the technology they consider is too early stage. So, so should you form a startup? When should you form a startup? So we were thinking about this, and thinking about this, and so I talked with Bob Langer at MIT, who has got, like, last count I saw, he had 23 startups. I'm not sure what he's up to now. And basically, his idea was that, you know, if you have a platform technology, a disruptive technology, a solution to a new need, or a revolutionary solution to a long unmet need, then that's a technology that's really geared more toward a startup company and less toward a direct license. Could be. So he says it's a huge idea. You have a seminal paper around it. You can create a blocking patent, and in the case of what he does, preliminary in vivo studies. And if you can have all of that together, that's sort of his gauge for how he decides if something should be a startup company. So if you're considering a startup, one thing to recognize is that university startups generally need a long time to mature. So when startups were studied out of MIT, 2 failed after about 10 years, 2 were acquired between 8 and 10 years, and 6 were still in business that they were following with durations from about a half year to 10 years. So most of these startups take about 7 to 10 years to mature, and that may be because we're trying to do something really ambitious. It's also because we start with discovery and we need to perform the product, as we talked about earlier. We need to shape the market a little bit. So that's just the general statistics. And then with startup management, once you decide to go down that path and you want to form a company, then you need to think about the people you need to know to do that. And in academic research, we have, faculty, students, our funding agencies, university administration, industry and tech transfer. But the startup, we need to also meet more attorneys, investors, people in economic development, business executives, maybe talk about an incubator or an accelerator. So there's overlap certainly with the groups of people that we'll work with, but we need to expand our network in a different way. There are also different models that have been studied by people, smart people in the business school who look at academic startups, and looking at different models for startups. So it used to be that if you're having a startup, sometimes the faculty would just leave the university and go do the startup. I think John Hennessy did that out of Stanford. So you could leave, take a leave. But most people don't do that now. Most people remain with the university, and they may partner with a faculty member with an experienced entrepreneur, faculty member with a grad student or a postdoc. A faculty and postdoc may partner with a business student, or just the students may do it, the PhD postdoc or the business school student with no faculty involvement, or faculty serving as an advisory post. So faculty members can generally look at a C-level position, be a board member, or be an advisor and stay sort of just on the sideline of the business. Regardless of the approach that you take, it's interesting that the faculty member, I don't know if you can see this fully, the faculty member is very active in the beginning of the process, and then as time goes on, the faculty member's contribution tends to decrease as the business sort of part increases. So the faculty member seems to be really important in the beginning of these processes. And then, after a while, the science is done, it turns into a sales and marketing organization, and the faculty participation can decrease if you're not going to take an active role in that. And then these different models I was talking about, this percentages of the percentage of academic startups that follow those models. So the most common one are the first two, but the second one is the partnership with a PhD, a partnership between the faculty and a postdoc. That's typically how some of these get, 41% get started. So also along the management side, finding a CEO can be the toughest. That can be a very hard part when you do need to start to get a CEO involved, if you're coming at it from a science academic side. So I interviewed about 15 or 20 people for the book that I wrote, and I asked everyone about finding the CEO, and everybody, including Bob Langer at MIT, told me that this was the hardest part of the whole process for them. Who is going to be the CEO entrepreneur to go the distance, with you, or at least get you through the startup phase? So things you want to look for: a high degree of integrity and ethics, seems obvious. Honesty, creative thinking, someone with charisma, who has a good presence, who can help lead you through investment rounds and be convincing and definitely representing, believing in the startup. Someone who's a risk taker, but not a crazy risk taker. Someone who takes measured risks, personable, and a strong work ethic. And so you have to interview them like you would interview everybody else. And I think you need to really spend some time, get good references. If you're giving equity, vest that in increments over a period of time, so you're not sort of all in with somebody that if they walk away, your business is sort of tied up. So that part is something that takes, it seems to take us quite a lot of time as academics to do. And then for the graduate students and postdocs who may be listening, or for those of you who are thinking about going into a business with graduate students or postdocs, there are potential conflicts of interest to consider. If, for instance, there's a graduate student in your group and you're the faculty advisor for their thesis and you're both starting a business together, it's not impossible, but things can be conflicted. And so there are ways to try to manage that conflict through the university, and your university may have guidelines. Sometimes universities will change the primary advisor so that there's just another party involved who can mitigate any of the academic components that maybe bring risk and conflict to the situation. So that's something to consider if you are a grad student or a postdoc, just kind of get that laid out. You're also kind of negotiating an equity position and salary with your advisor, which can be a little awkward maybe, so that's something you have to think about. The risk of working for a startup if you're a grad student, it's a full-time commitment for you, while faculty members kind of keep their day job as faculty members. So, you have to be kind of committed to that and willing to take that risk. As we said, it's higher risk than normal business, but again, also a tremendous payoff potential, both financially as well as most importantly, the impact that you make on society. So to think about that and your potential of risking your lost opportunities for other things while you're doing this. So, and then my recommendation is also to get a formal education. So the startup world is just different from a lab, and the more you can learn to maneuver in that world, learn the language, the proper lingo, and be able to know more of the details on the business side will be helpful as well. So putting together your startup team is really a very important part. Someone was just telling me, if you have, in your first 20 employees, if you have one bad hire, that's okay. If you have more than that, it's going to really impact your business and so on. So your board of directors, putting that together, your C-suite, when you get to that, board of advisors, consultants, people who you contract with, and your employees, and how you bring them on, and the strategy for that. So I'm showing you a good team. This is Villanova's basketball team from 2018. So they had a good team that year. And then ways to get accelerators and ways to get you started. Accelerators and incubators are two different approaches. The accelerator being like a short-term sort of boot camp. Sometimes they take equity for in your company for going through their training. There's usually common space with other like-minded, like a cohort of like-minded startups want to succeed and fail fast, and there's lots of opportunities there for presenting to investors at the end of that duration. And there are some extremely successful accelerators, especially on the West Coast. Where incubators are a little bit different. We have a very huge incubator in Philadelphia for medical and pharma called the Philadelphia Science Center. And those are more like a real estate deal where you can rent lab space and office space for a longer term time. You're also with, startups in there, but you may or may not have sector selectivity. It may be all in your sector, it may be in a different sector. And you can sometimes share office and lab facilities and resources like accounting and legal advice and things like that. So two different ways of looking at that. Yeah, accelerators, 73% of the 1,200 incubators, accelerators are in the US and are affiliated with universities, economic development agencies, or government entities. And incubators, startups using incubators have an 85% success after 5 years compared to 35% success over the same period if you're not in an incubator, if you have a startup and you don't use an incubator. So that sort of co-localization, sharing resources, crossover with other entrepreneurs seems to add value to the company and increase success. That's been documented in the literature. So we're getting to the fun part now, the financing. When you're ready to go into financing, generally need a business plan, either a slide deck or a real report type plan, which covers all the steps associated with the development of the business. And people can read these, or you can present these, and then they can see how well you've thought things through. It's great exercise for helping you just think through every step, and then you're trying to resource every step and making sure that your timing and your path and plan are feasible. So the funding, generally people will start by giving you a small amount of money, and if you're successful, they'll follow it up with a larger round. And so the first seed level funding can be by your own funding, your friends, your family, or something like your university that may give you proof of concept funds, or a university investment fund, or regional. We talked about these regional state funds potentially. One time I did one startup with funding from self, friends, and family, and it was a wonderful way to get it started. But it was really rough to see all those these friends and family socially, and you've got their investment money and you're trying like crazy to I was so glad when we sold that company I got out of that. That was a very hard way to go, I would say. So and then getting a little bit more follow-on funding. You have all these possibilities, including venture capital, which has its own strengths and challenges associated with that. But there's a system now that if you can, people are trying to do these kind of lean startups, in that they're trying to keep them small and build value with a small group, not take the venture funding until you really have to and you need to accelerate, so that you use the venture funding when you already have built value, so you don't lose as much of the value when you get that venture funding. So all these other things are possibilities to help get started. And then they can there are angel networks that can, you know, kind of get you going in the beginning. There's Golden Seeds, which is an angel network just for female entrepreneurs. Just throw that out there. I think they're great. There's also Corporate Investing Group and Corporate Venture Capital. They're typically not a lead investor, but they are really nice, and they use that a lot of times to take a look at the company and see if they want to buy it, if you're successful. And then, of course, regular venture capital, usually post-seed with a range of values. They may assume a board seat. They may change your management team. So these are all considerations that they have. And something that is intriguing to me are crowdfunding platforms. There have been a couple companies that have gotten their seed money from the crowd, from crowdfunding, and there have been changes in laws state by state to accommodate crowdfunding, and in the U.S. and then internationally. And so this is something I'm just sort of still following along. It's a newer way of going with things, but there've been some companies. One in the UK raised 800K just from crowdfunding their startup, and it's set up now that people if there's a crowd and you invest a minimum amount of money, then the crowdfunding platform will take care of all the equity mapping and keep track of all that for you. So it's not like you have, you know, 100 investors. It just basically treats it as one group for you and keeps track of all that. So I find that very intriguing, and we'll see where that goes over the future, I think. So just want to summarize that this path we've been down is kind of a roadmap for how to think about and organize your thoughts around considering how to have high impact from your research, and if that's going to be through IP, if that's going to be through a direct license or through a startup company. They're all very exciting and all great ways to impact the world. And again, while I drew this very nicely, well, I didn't do it. Someone did it for me. Drew it very nicely. It's actually really like this. You're constantly circling back. You're constantly, you know, rethinking and iterating. That is the way design works. That's the way science sometimes works, and that's the way this works as well. So I don't mean to oversimplify it, but just you know, put it into a format we can at least use as a framework to discuss it. And then just the possible reasons why startups will fail. And this is a survey to give reasons why what people thought was a contributing factor to their startup failing. So these numbers don't add up to 100% because they could just, you know, say how many people think, you know, this is a problem. So no market need turned out to be the #1 reason why they thought the startup failed. This is how we started our discussion. Are we going down the right path? The second one was that they ran out of cash. The financing part the timing wasn't right, and they weren't able to get enough funding for their project when they needed it. And also not the right team. So that's another, you know, component we talked about. But so these are the top 3 reasons why startups may not work. So we talked about the difference between academic startups and non-academic startups. The likelihood of faculty participating in startups is linked to their training and local environment. Supportive environment for the university is important. Things like proof of concept centers, accelerators, incubators, university venture funds, entrepreneurs in residence, all these things with the tech transfer office are needed. If you go down this path, a successful academic startup typically averages about a 10-year commitment. And academics can be successful founders, and you can learn how to do this. It's not impossible. It's a lot of fun. It's extremely rewarding. It's a lot of hard work. It's extremely rewarding. I think it's a wonderful endeavor for academics to help to really find yet another way to impact the world. So I thank you for your time, and I'd be very happy to take any questions. Thank you.
Thank you so much, Michelle. This is maybe the most awkward part of these Zoom presentations, is that you can't hear all the applause which is taking place in distributed offices. But thank you so much. You know, I am so impressed that you took an incredibly detailed and complex journey that, as you nicely illustrated, begins with discovery all the way through deliverables, and you got us through it. That was that was just marvelous. So thank you so much for sharing those insights. We do have a little bit of time for a couple questions. So I'm monitoring the chat now. If you do have a question, please use that chat function. You can send me a private message or put it in there, and then I will moderate and call on people. Maybe as we're getting started though, Michelle, I was curious, you laid out this pathway and you nicely acknowledged that it's never linear, it never quite works out the way you think you will. As you reflect on the 3 startups that you've done, what was perhaps the biggest surprise that you encountered with one of those startups?
It's a good question. I think the first one really had no idea what was going on. Really relied on our CEO to help guide us through everything. And so I think I was just surprised at how much I was negotiating with companies and with everybody else, and, you know, constant negotiation, I think, and management of that. I wasn't prepared for that. And I think I learned that the most from the first startup. And I think the other thing is that the team is so important. Both good team. I agree with Bob Linger. Finding the right CEO sets the whole tone, and that is probably one of the most essential components to setting up a structure that can be successful.
That's great. Thank you. I'm going to go to Ellen Eishin, who has a question about patents. Ellen, if you'd like to unmute yourself, please go ahead and ask your question.
Yeah, here, I'll show you my face also. I was curious, you mentioned, I think when you were talking about Bob Langer's advice, you mentioned a blocking patent, and I was wondering how often that's necessary or recommended.
I think the only real value to the technology in the beginning, because you don't really have a product in sales, the only product that you really have is the intellectual property or the patent around it. So a blocking patent just means that that patent will prevent other people from, really prevent them from getting into your area. And so you can start with a fundamental patent that covers the original part, and then you can protect it with kind of a fortress of other patents around it as you go along, and you get more detail in there. So yeah, his idea is a blocking patent. So I'd say it's sort of essential. Otherwise, people can copy what you're doing very easily.
Thank you.
Thanks, Ellen.
Thanks. And I'm going to exert some privilege. We're slightly over time, but we're bleeding into Bob Goldberg's private time, and Bob has our next question. So I'm going to wrap up, if it's okay, with our last question from Bob himself. Go ahead, Bob.
Sure. Thanks, Michelle, for your great presentation. My question was related to regulatory factors and whether you had any data on how the time and cost to market, which, of course are related, affect the pathway that is typically taken from academia, between a license and a startup.
Yeah, I mean, the regulatory pathway I'm most familiar with is FDA regulatory pathway, but, other markets have other regulations and pathways.
Well, I'm thinking like predicate 510K versus like a PMA.
Yeah, so the thing, 510K, for those of you who don't know, is kind of a device that's predicated on a pre-existing device. So it's similar enough that you can go through a shorter regulatory pathway, maybe without or with limited clinical trials, where the PMA is sort of full out clinical trial, longer, much more expensive process, but you may be the first one to market if you do that. So it depends on your strategy. You can get, I feel like the 510Ks are kind of like singles or doubles, but if you go for a PMA, you're swinging for the fences, kind of. So it depends on your technology and what you have. I've also found it interesting that you can get a patent for something innovative and then get a 510K because it's exactly the same as something else. So you can do that, and I've always found that an odd twist of federal policy. So yeah.
Thank you so much.
Thank you.